Problem 1.4, use resistor color code table to find resistance of following resistors. So if you look at a resistor color code table, you'll see that each color is associated with a number. So how do we put those numbers next to each other to find the resistance of these resistors? First step is to count the number of color bands on your resistor. So first one has 4 color bands, second one has 4 color bands, third one has 5 color bands, and fourth one has 6 color bands. So for all resistors that have less than 6 color bands, we'll do the following process. Let's start with this one. So the rightmost value or color is going to give us a tolerance value. So what is tolerance? Well, let's say I had a 100 ohm resistor with a tolerance of plus minus 10%. So what this is saying is that the actual resistance of this resistor is different than what the manufacturer rated. Manufacturer rated it at 100, but the actual resistance might have some error in it. So it might range from 100 times 1.1, which is 110 ohms, all the way to 100 times 0.9, which is 90 ohms. So before using this resistor in your circuit, you must measure it because it has a very large tolerance value. 10% is huge. Okay, so what we're gonna do with all these resistances is first write their tolerance values. So silver is plus minus 10%, gold is plus minus 5%, and brown is plus minus 1%. Now, the color before the last color band is our multiplier. And multiplier, all we're going to do is do times 10 to the power of, and in this box, you're going to put the number that the color represents. So red is 2, so I'll have 10 to the 2. Orange is 3, 10 to the 3, and black is 0, 10 to the 0. And the rest of the numbers we're just gonna put them next to each other. So green is 5, blue is 6, brown is 1, black is 0, green is 5, red is 2, brown is 1. And because of that, we have a 5.6 kilo ohm resistor plus minus 10%, a 10 kilo ohm resistor plus minus 5%, and a 521 resistor plus minus 1%. One thing to notice is that with 5 color bands, I got a more precise value for my resistor. I have 3 digits that make it more accurate. And for 6 color band resistors, what we're gonna do is for a second assume that the last color doesn't exist. Just make it disappear. Do the same process. So red is plus minus 2%, black is 10 to the 0, and then I have 274. So here I have a 274 ohm resistor plus minus 2, and the last color band gives us the value for temperature coefficient of resistance. If you remember, in the resistivity section, we said that the resistivity of materials can change with temperature, and we use the following equation to find the change in resistivity with temperature. And we used the letter alpha to represent temperature coefficient of resistivity. But here we have TCR, which is literally the same thing. But before you use TCR, always check what the units are. So on the color code table, you might see parts per million per Kelvin. The examples that we did for alpha are in Celsius, but it doesn't matter Celsius or Kelvin because our temperature is a difference, and Kelvin difference is equal to Celsius difference, so it doesn't matter. But when you have a parts per million, you need to make sure that you include this 10 to the negative 6 in your equation before replacing it with alpha.